Hello everyone. In this video, I'd like to talk to you about some basic statistical concepts. We'll start first by talking about the mean, median, and mode. Now these are concepts that most of you are, I'm sure, very familiar with, but I do want to go over them just so that we can make sure that everybody understands what they are, so that when we talk about them, everyone will know what we're talking about. After we talk about those, we'll go into some other concepts that might not be as familiar to everyone. We're going to talk about quartiles, and then the IQR, which stands for interquartile range, and then we're going to talk about outliers and how we might be able to identify outliers in our data set. So first of all, let's talk about the mean. So when you hear someone state that the mean of a data set is some particular number, that always means just the average. So basically what we do is we take all the numbers in the data set, add them up, divide by however many numbers there are, and that gives us the average, which we call the mean. So for this group of numbers here, we would take the sum of all of them, divide by the total number of values. So there's 8 values, so we would add all of them up, divide by 8, and we get 4.375. So we might be tempted to state that the mean is 4.375, and we could, that's okay, but it's common practice to just take one more decimal place past what the raw data is to use for rounding for your means. So for instance, in this case, the raw data was all in integer form, whole numbers. So we would then say, okay, then when we find our mean, we're willing to go, let's say, one more decimal place past that. So we would then want to take this 4.375 and round it to something with just one digit past the decimal point. So that would be rounded to 4.4. So that's what we would say, is that the mean of that data set is 4.4. Okay, now what about the mode? The mode is the value that appears more often than any of the others in the data set. Now in this case here, if we can look at all these different values and try to figure out which of these appear more often than the others. And actually in this case, they all just appear once. So we would have to say this data set does not have any mode. Okay, and that's perfectly fine. That sometimes happens. There is just no mode for a particular data set. Here's another one though. If we look here, we see that there are 2 2s, and everything else seems to appear just once. So we would say that since 2 appears more often than the others, then it would be our mode. So we would say that the mode of this data set is 2. Here's another one. If we look at this one, I see 3 8s right away. I do see 2 4s. So 4 does appear more than once, but 8 beats it out because 8 appears 3 times. So we would say that 8 appears more often than others, so 8 would be the mode of this data set. Here we've got 4 showing up 3 times and 8 showing up 3 times. So both of those numbers, 4 and 8, show up 3 times each. So they're tied, and so it's possible to have more than one mode. So what we would say here is that 4 and 8 are both modes. So sometimes we say this is a bimodal data set because it has 2 modes. So we'd say 4 and 8 are the modes of this data set. Okay, so now I have a question for you. Can you think of any circumstances where the mode could be found for a data set, but the mean could not be found? So what type of data set could there be, so that you could find the mode but can't find a mean. Now what I'd like you to do is think about this for a minute, even pause the video here in a second. I'll tell you when to pause it, and see if you can think of this. It's kind of almost like a riddle. It might be something that you don't think of right off. So if you don't worry about it, but once you do either think about it or find out the answer, then I do want you to be very aware of this situation. So, okay, so go ahead and pause the video here and see if you can think about some situation, some type of data set where the mode can be found but the mean cannot be found. Okay, here is the answer. When the data values are not numerical but are categorical, we can't find the mean because we can't add up all the values and then divide by a number because those values aren't numbers to begin with. So when we have categorical data, in this case here it looks like we've got M's and F's, so those probably stand for males and females. So you see that there's no numerical value, so we can't add them all up. But it's very true that it's very easy to find the mode. You would just need to look and see which of these values appears more than any of the others. And in this case here, F appears 4 times, but M appears 1, 2, 3, 4, 5, 6. So we would say that M is the mode, but that we cannot find a mean for this data set. Okay, here's another concept we need to talk about, median. So median is the halfway point in a data set. So what we need to do in this set here that you see, it is not in order. And it's really important that you remember when finding the median to put the data set in order first. Because if you use this technique that I'm going to show you here, but don't put the values in order, you won't get the right answer. So here is a set of values. And first of all, let's put them in order. So we would arrange the data in order, and this is what it would look like. Okay, once it's in order, then what we do is now see, we're finding these values here from when we're talking about the mean and the median and even the mode here this week. We're finding these for very small data sets. I'm wanting you to learn how to do this just the what we might call the old-fashioned way by definition, because I want you to understand how these values are found. Obviously, if you have a large data set, you're not going to do what I'm going to show you here. You're not going to by hand write it out in order and then go from there. You're going to use something. We'll be talking about how to find this in Python. You might use R. You might use any number of other software packages, or even just a graphing calculator or something like that. So it's not that I'm not saying that this is the way you will always find the median, but I want you to, this week, when we're talking about the median, do it this way so that you are very familiar with how this is actually found. But I'm never going to give you a very large data set just so that it won't be a lot of busy work for you to find the answer here this week. Okay, so this is our data set. What we would do, here we can, because it's a small data set, we put it in order, and then we're going to kind of start at the ends and kind of march in towards the middle so that we find the middle point, because remember, the median is the halfway point in a data set. So we start at the 0 and 9, and we'll go in and keep going one at a time until we find a middle value. In this case, we did have a middle value. We had the value 4 is right there in the middle. And you might be thinking, well, what if there's not a middle value? What if there's 2 middle values? We'll talk about that here in a minute. But in this case here, there is a middle value, so we would say that that is our median. So our median is 4. Here, it's almost the same data set, I believe. I just changed one of these numbers to a very big number. So if we arrange it in order, it looks like this. And again, to find the median, after we arrange it in order, we march in from the ends all the way to the middle. And again, this is the same median that we found before. It's the middle value, which is 4, which is interesting because we have that huge number at the very top, 931. Notice that the median was not even affected by that, by the fact that we took that large number and made it huge. It didn't even affect the median, because if the median is the halfway point, really extra large numbers and really extra small numbers, they're not going to influence the median, because it's all the median is just the halfway point in the data set. So here again we would say the median of the data set is 4. Okay, here's another set. We're going to put it in order first. And this is one where when we start at the end and march toward the middle, we find there's no middle value. There's 2 middle values. In 38 and 52, that's as close to the middle as we can get. There's nothing in between them. And so the way that we find the median is we just take the average of those, take the mean of those 2 values. So we would add up 38 and 52 and divide by 2, and that would give us a 45. So we would say that the median of this data set is 45. Okay, here is a practice problem. For these practice problems, it would be nice after I explain the problem, I'll tell you when to pause the video, but after I explain the problem, pause the video and then try this yourself, and then you can start the video up again and see if you match my answer. Okay, so the problem is this: we've got a data set. Find the mean of that data set, the median of it, and the mode. So find all 3 of those: mean, median, and mode for this data set. Okay, you can pause the video now and then restart it once you've found your answer. Okay, now let's check your practice work, see if this is what you got. The mean, if you would want to round to 1 more decimal place past the raw data. So the raw data, all that data in the data set is whole numbers. So the mean, then you would round to 1 decimal point past that. So we'd say the mean is 42.5. The median is 45. And if you didn't get that, it's probably because you forgot to put it in order first. Now the mode, there's 2 modes, 26 and 45, show up the same amount, same number of times. So we would say that the data set is bimodal and the modes are 26 and 45. Okay, now here's a question that's similar to one we've already asked, so I think you'll be able to get it this time for sure if you weren't able before. Can you think of a data set that would not have a mean or a median, but that could have a mode? So I actually put this in here kind of forgetting that I already had that slide from before. So anyway, but kind of as an extra emphasis, hopefully you know the answer to this, and that is, if we have a data set that's made up of categorical data, it wouldn't have a mean and a median, but it could have a mode if there was something that appeared more than the others. So if I were to ask members of my family what their favorite colors are, and if I were to get this, then I obviously could not find a mean, and I couldn't find a median because these aren't numerical values, but I could find the mode if there is one. So blue shows up more than the others, so I would say that the mode is blue. Quartiles is another concept that is a basic concept that is good to know when we're talking about data. Quartiles are values that divide the data into 4 groups. Just like the median divided the data into 2 groups, quartiles divide the data into 4 groups. So we'll need 3 numbers, Q1, Q2, and Q3, in order to divide the data into 4 groups. Okay, so you'll see my explanation right here on the slide on how to find the quartiles. I'm not going to read that now because it won't make much sense until we actually do it. So let's look at the numbers I have and let's go through the process, and then after we do it you can look back up and realize that what I have there as the method hopefully then will make sense. So let's say we have this data. What we would do first is find the median. So we'll need to put it in order and find the median. And so to do that, again, we start at the ends and march towards the middle and find the middle value if there is one. Looks like there's not a middle value, so what we'd have to do is find the average of that. So 5 plus 6 is 11 divided by 2, so that's 5.5. So that's the median, but it would also be called Q2, the second quartile, if we're finding quartiles. So the median is Q2, and we find that first. Then what we do, excuse me, is find the median of values above Q2, and that's going to be Q3, and then find the median of values below Q2, and that's Q1. Okay, so we'll start down below here. So right below Q2 is the 0 up to 5. So we will start with 0 and 5 and then march in to the middle there. Now again, there's no middle, so we will take the average, and that would be a 3. So Q1 would be considered the value 3. Now we'll take everything above Q2, so that's starting at from 6 up to 23. March into the middle, and we see 8 and 9, so the average would be 8.5. So we have Q1 is 3, Q2 is 5.5, and Q3 is 8.5. So again, what we did first is found Q2 by finding the median. Then we looked at everything below the median to find the median of that, and that was Q1. We looked at everything above the median and found the median of that, and that was Q3. Okay, here's another example. Again, what we would want to do to find the quartiles is first put it in order. So we put it in order, and then we find the median. Find the median here. Now in this case, it might not look like it, but 9 is the middle value. These other ones have more digits in them, so it almost looks like 9's not in the middle, but it is. Okay, so 9 is the middle value. So this is a little different than our last example, because our last example, we didn't have a middle value. We had to find an average. Here, though, we actually have a middle value. So the question, your question might be now, when I go, that's going to be our Q2, right? Q2, 9 is our Q2. Now the question is, should I use 9 in trying to find Q1? So should I look at the values from 1 up to 9 and find its median? Or should I look at just the values below 9, so 1 up to 8, and then find the median? So actually, sometimes a person will do it, as you know, you'll hear somebody do it one way as opposed to the other. The way I'm going to describe, and the way I think that's most common, is that you're going to not use Q2, and you're going to start with everything below Q2. And so that's the way I want you to do it, and the way I'll want you to do it on your tests. So everything below Q2 is the 1 up through 8. So start there, march into the middle, and find the middle value of just those values, and that's 5. So 5 would be our Q1. And same thing on the other side. Again, we're not going to use 9 in order to find Q3, sorry. We're going to ignore the middle and just start with the 16 and 43 and go into the middle there and find that value. So that value is 19. So we would say Q3 is 19. So Q1 is 5, Q2 is 9, Q3 is 19. Okay, here is a practice set. So I've given you some numbers, and what I'd like you to do is to pause the video here in a minute and then take those values and find Q1, Q2, and Q3. Okay, go ahead and pause the video now. Okay, now let's check your work. So you should have gotten 26 for Q1, 45 for Q2, and 56 for Q3. A box plot is a way to represent your data in kind of a visual way. what a box plot is going to show you is you're going to be able to look at a box plot once you understand what it is, be able to tell what is the maximum value represented in the data, what's the minimum value represented in the data, and then what is Q1, Q2, and Q3. And if you know what Q2 is, then, of course, if you're asked what's the median of the data, you know, oh, I just need to find Q2, and Q2 is always the median. So you would be able to find the median also from a box plot. So let's talk about how you would go about creating a box plot. Oh, before we do that, though, IQR. If you look and see the line that I have between Q1 and Q3 is labeled IQR. IQR stands for interquartile range, and what that is basically the range, the distance between Q1 and Q3. So you're going to take the Q3 value, subtract Q1, and that will get you the IQR. Now there's a reason we're finding this IQR. It's going to be helpful later for us to be able to determine if a value is one that we might consider what's called an outlier. We'll talk about outliers here in a little bit. But anyway, there's a reason why we're talking about this now because we'll use it later. So IQR is always going to be Q3 minus Q1. So here's an example. Let's draw the box plot and then also see if we can figure out what the IQR is. So this was an earlier example where we already put it in order and found Q1, Q2, and Q3. So what we would do is basically we would say, okay, the lowest value is 1, the highest value is 43. So we'd want to make our numbers go from 0 up to somewhere that's going to be at least as big as 43 or a little bit bigger so that we can get all of our data values represented there. So imagine this, you would first of all put a line where the minimum value is. So our minimum value in our data set is 1. So you would go over and notice down there at 1, there's just a horizontal line. Then you would go up to the top and see that horizontal line up at the top that represents the maximum value. So that would be a 43, so you'd put a line there at 43. Now what you do, so far now all you should have is just the bottom little line for the minimum and the top line for the maximum. Now, before you draw that box, all you need to do is put a line at Q1, Q2, and Q3. So Q1 is 5, so you would go and where you see 5 on that, just put a line. You can it's going to be a little longer than your first line for the minimum, okay? So you put a longer line there, and then that same length of line for Q2, and then another one just that same length for Q3. So now you have lines for minimum, maximum, Q1, Q2, Q3. Then you take those lines that represent the quartiles, Q1, Q2, Q3, and then connect them together on the ends so that you make a little box. Okay, so now you have a box. So that's why it's called a box plot. Sometimes it's called a box and whisker plot because you see these little lines on the top and the bottom that are kind of like whiskers. And so that would be the box plot that we could create for this example. Now there is one little issue that we need to talk about here in a second. So we're gonna say this is the box plot, but don't take my absolute word for it right at this moment because we're going to come back and make one little change to this eventually. But so far, this is how you would start in order to create a box plot. Let's talk about IQR. What's IQR? That's Q3 minus Q1. So that would be 19 minus 5. That would be 14. So IQR is 14. So again, as I said, there is a little problem with this box plot that we need to make one little tweak, one little adjustment. But again, this is how you would start, but we need to talk about outliers in order to be able to figure out what else needs to be done with this particular box plot. Okay, outliers. What are outliers? So many of you probably understand this concept of outliers or have heard about it before. An outlier is just some value within a data set that just seems extremely high or extremely low, almost like suspect, like what? How could that number, how could we get such a big number, or how could this number be so small? But sometimes it's very, very possible that you can get those. But anytime some value is just extremely high compared to the others or extremely low compared to the others, you would say that might be an outlier. That might be something I need to look at a little bit more carefully. So here's an example. Here's a data set. Let's imagine that as a data set. We might, if we put it in order, I'm going to put it in order. If we do that, we see that mostly all the values are in the 20s and 30s. There's a few that aren't. So 20s and 30s. So it looks like there's a 1 and a 9. Those look a little bit out of place. And then especially the 90 and 125, those look out of place if you're realizing that, these mostly 20s and 30s. The 56, maybe even 2, you might think, is that even right? So now, when we're questioning whether something's an outlier or not, it doesn't mean that it's necessarily a bad number. Maybe it's a valid data point, but we just want to look at these extremely high and extremely low values, and we're going to learn how to use a little bit of common sense to be able to know whether that's something even we want to consider as part of our data set or not. So anyway, we'll talk about that here in a minute. But looking at that, we might think that 1 and 9 seem a little small, and 90 and 125 seem a little big. But now, let's see. I think my voice might have cut out on that last slide. So we'll continue talking about the same data set right here. So this data set here that we were looking at before, we said 1 and 9 is kind of looks like pretty out of place, maybe, and then 90 and 125 looks a little out of place. Well, what we have to do with outliers is kind of think about them, and they might be a valid data point. So it might be the result of some error, though. Maybe somebody wrote something down wrong, or they measured it wrong. So outliers can be the result of measurement or observational errors, but they also could represent valid data points. So what you have to do is use your own judgment to help you decide how each one of these should be treated. Sometimes we want to throw the values out and say this can't be a valid number, so I'm not even going to consider it as part of my data set, because if I'm finding the mean of something and I have a number that's clearly impossible, I don't want to include that in finding my mean, because I know I would get something that's not correct. So anyway, the question is, you don't always know. Is it a result of measurement or observational error, or is it a valid data point? You just kind of have to use your judgment to decide. Now, that same data set, if I were to tell you that data represents ages of college students in, let's say, one of my classes, how would that help us determine which of these might be considered, impossible values, and which might be okay? Well, any in the 20s and 30s, those would obviously be ages of people in a college class. Even the 50s would be. Now 90, let's look at that. Is that possible? It is possible. Not too many 90-year-olds are taking college classes, but I know for a fact there are some who do. So 90 would be something we'd have to think about and say, well, it's not absolutely impossible. Maybe there really was somebody who was 90 years old. The 125, though, we know for sure. Nobody, I don't think, has ever lived up to 125. So that 125, no way, that couldn't happen. Down to the bottom end, number 1, the number 1, that would represent someone who's 1 year old taking a college class. We know that's impossible. So 1 has to be an error, because no baby could be taking a college class. However, 9, that might be something like, well, you do have child geniuses, people who are really way ahead of their peers. So it's not totally impossible for a 9-year-old to be enrolled in college class. It's pretty unlikely, but it's possible. So anyway, here's what we would do, what we would look at and think about when we're looking at this data set. We'd say for number one, no way. There's no, if these really represent ages of college students, there's got to be a problem there. We're either going to throw it out or replace it in some way. We'll talk later about how we might replace values that we don't think are valid. And then the 125, again, no way. We would throw that out or, replace it with something. With 9, well, again, maybe that's possible. And again, you would use your own judgment. One person might come up with saying, no, there's no way, I'm not going to even leave 9 in there because I don't think that's possible. Somebody else might say, oh, but no, there's really a possibility that somebody 9 years old might have been enrolled in a college class. So it's your own judgment. One way is not necessarily better than the other. You just decide yourself. And same way with 90. Maybe it's possible. So you could keep it in or replace it or throw it out, whatever you think of, whatever your judgment tells you to do. Okay, so now, we looked at that and kind of looked at some values and saw that, yeah, those numbers look extremely small or extremely large, but is there a mathematical way to determine whether we should consider something an outlier or not? And there is. So here's how, and this is why we needed to understand what the IQR is, the interquartile range. What we do, take a look, this is kind of like a part of the box plot. Over on the right, it's like part of a box plot, but it doesn't have everything in there, but it has Q1 and Q3. And remember, IQR is the distance between them. So Q3 minus Q1 is IQR. So what we're going to do is notice you see it says if a value is below Q1 minus 1.5 times IQR or above Q3 plus 1.5 times IQR. If the value is in either of those ranges, below the one value or above this other value, then we would consider it an outlier. That's the way we would mathematically determine if this should be considered an outlier or not. So let's see if we can visualize this. So over to the right, you see the IQR. Let's look at the one below. So it says if a value is below Q1 minus 1.5 IQR. So see that yellow band, yellow little box? We're going to take that and multiply it by 1.5. So we're going to find a box, come up with a box that's that size plus another extra half. So you see that we've got the one full IQR is the box the same size as IQR, and then the 0.5 is a little box that's 1/2 the size of IQR, and we take that and we put that below Q1. So looking again at that first little phrase, if a value is below Q1 minus 1.5 IQR. So you see how at the bottom of that bottom blue rectangle, that would represent Q1 minus 1.5 IQR because we took 1.5 IQR and subtracted from Q1. So that value down below there, that would be the value at which anything below the end of that blue rectangle, anything down there, we would consider an outlier because it's below Q1 minus 1.5 IQR. Now let's do it for up above. So again, we would take IQR, but then find IQR times 1.5. So we're going to put a box that's the size of IQR above Q3, and then take another half box size of the box that's half that size and put it up there too. And then that value there would represent Q3 plus 1.5 IQR. So we added that to Q3, whereas before we subtracted that amount from Q1. So now we would say anything above that top line represents a value above Q3 plus 1.5 IQR. So that then we would say is anything up above up there, we would also consider an outlier. Okay, so hopefully you followed this. It's a little hard when you don't see me pointing at these at the graph as I'm talking. So hopefully you can understand that. If you do have questions, and after you see some more examples, if you still have questions, definitely email me or yeah, email me or call me, and I can maybe try to describe it better or even give you a more detailed um, video just for this one little problem if you want, but hopefully you understand this. Okay, so again here, in other words, any data point more than 1.5 IQRs below the first quartile or above 1.5 IQRs the third quartile is considered an outlier. So going back to our earlier example, if we find the IQR as 14 here in this example, and then we would take 1.5 IQR to get 21, and so add that to Q3. That would be the upper bound at which anything above that would be considered an outlier. We actually have a data value, our highest data value is 43. So we would say that because 43 is above this Q3 plus 1.5 IQR, then we would consider it an outlier. So instead of having the box plot look like that, we would do this instead. We would put an asterisk for that 43 because we want it known that that was a data point, but we don't want it part of the whisker because it's a little bit too high to be considered a regular data point, and we would want to consider it an outlier. Then the top of that whisker then would be just the next highest data point that is not considered an outlier. Okay, so below 43 is the data value 25. So for the 43, we have that as an asterisk, but then the whisker only goes up to 25 because that's the highest value that's not considered an outlier. Okay, so that's how our example would change once we realize that we have an outlier there. Now also for the bottom, we found this outlier at the top. Look at the bottom, and we would want to take Q1 minus 1.5 IQR to see the limit at which which would determine outliers on the bottom. So Q1 minus 1.5 IQR ends up being a negative 16. Now, if we had any data values that are less than negative 16, we would call those outliers and we would put an asterisk by there. But as you can see in this example, the smallest value is 1, and 1 is well above negative 16. So that would tell us that we don't have any outliers down at the bottom. So there's no need to make any changes to this graph at the bottom. But in another example, if you do find any outliers, you do the same thing on the bottom as we did on the top here. You would put asterisks wherever you see outliers and then adjust that whisker so that it represents in this case, if we're talking about the lower part, it would represent the lowest value that's not considered an outlier. So, and sometimes you might have more than one outlier. So in this example, we only have one asterisk, but you might see several asterisks up there, meaning that there's more than one. But in this case, there was only one. Okay, here is a practice problem. What I'd like you to do is for this data set, determine which of the data points are outliers based on the formula that you just learned. So you're going to have to, of course, find Q1, Q2, Q3, find 1.5 interquartile range, and use those formulas to determine if there's any outliers there. Once you determine that, then you're I want you to draw a box plot and be sure and represent the outliers with asterisks. So you're going to draw a box plot based on how you've learned how to draw a box plot in the past. But again, don't put any of the outliers as part of that whisker. You're going to make sure you want to put asterisks there for the outliers. Okay, so go ahead and do this, and I'll go ahead and have you pause the video here and go ahead and solve this. Now here's the solution. We find Q1, Q2, and Q3 after we put the values in order, so don't ever forget to put them in order. So we found those. We find the IQR, which is 34. Then 1.5 IQR ends up being 51. And so if we take Q3 plus 51, we get 208. So we know that anything over 208 is going to be considered an outlier. We look up and we see that there is a value bigger than 208. It's the 217. So that is going to be considered an outlier. Then Q1 minus 1.5 IQR gives us a 72. And so anything smaller than 72 will also be considered an outlier. So looks like 65 is a data value and it is less than 72, so we would consider the 65 an outlier. So here, looking over to the right, you see that we have placed an asterisk at the 217 and the 65. And then the box, the inner box there, you see that the middle line is at the height of 145, which is Q2. And then you see Q3 is represented by kind of the top of the box, and Q1 is the bottom of the box. Then the whiskers come in. The whiskers there are only going to go up. The top whisker will only go up as high as the highest data value. So 217 was an asterisk, so it's not part of the whisker. So ignore 217 and then see how high does it go. It just goes up to 160. So 160, because this top of the whisker should be representing the highest data point, the maximum value, and we're going to say now while not considering outliers. So 160 would be the top of the whisker, and then the bottom whisker, the bottom of it will represent the minimum value, but again, we're not going to consider outliers. So the minimum value, ignoring the 65, would be 120, and so that would be the bottom of that whisker.